Hey everybody, this is part 2 of the practice quiz explanation for quiz 6, solving equations with special cases and distributive property. I'm going to not have as much of an in-depth explanation as the distributive property of the distributive property in this video. So if you need more explanation for that, please make sure that you start with the other video that goes over problems 1 and 2. So I'm going to try and get 3, 4, and 5, the Beyonce problem, into this video. All right, so let's dive in. Anytime I see parentheses like this, I should know that that's where I'm probably going to start. Okay, so I'm going to do that distributive property first. Remember, that just means that whatever number is in front of these parentheses is being multiplied by both of these numbers individually. So on the left, I have negative 2 times x, and I have negative 2 times 1. On the right, I have negative 4 times x and negative 4 times negative 1. Okay, so I'm going to bring down that 5. I'm not going to change that yet. Negative 2 times x is negative 2x. Then I have negative 2 times positive 1. So again, that's negative 2. All right, that's equal to, I'm still going to have this 2. I'm not changing that yet. Then I have negative 4 times x, which is minus 4x. And then I have negative 4 times negative 1. So we got to be careful here because a negative times a negative is a positive. So here I'm actually going to add 4, not subtract. Okay, so be careful there. Is that clear? That's not really any better, is it? Maybe a little. Okay, so now I've done my distributive. So my next job is to do some zero pairs or combine like terms here. So I've got a 5 and I've got a minus 2. So 5 minus 2 is 3. So I have 3 minus 2x. That's what I have on the left, right? I still have that negative 2x. 5 minus 2 is 3. All right, over here, I have a positive 2 and a positive 4. So altogether, I'm going to have still that negative 4x plus 6. Okay, now I have all of my zero pairs done. My distributive property is done. So now I need to start doing those matching sets. So right away, I see that I have negative x's on both sides. Okay, so I see 2 negative x here, and I see more than 2 negative x's over here. So to get rid of that, I'm essentially adding 2x to both sides. Right? If I have a negative x and I add a positive x to it, that equals 0. So then those cancel each other out. Okay, so by adding 2x here, those go away. That's 0. So now I just have my 3 left over here. On my right, I had negative 4x, but then I added 2 positive x's. So now I have negative 2x, and I still have plus 6. Okay, so now you guys could be thinking that we have 3 ones on both sides that we could take away. But if I do that, I'm still going to have more ones left over here, right? I would still have negative 2x plus 3 if I took away my 3 ones from both sides, right? And remember, my goal is to have all the x's on one side and these terms without variables over on the other side. So instead of taking away 3, I'm actually going to take away 6. But remember, that means I have to do the same thing over on the left. Okay, so that means over here I have 3 minus 6. So my answer is going to be negative now. So I have negative 3 on the left. On the right, those 6's went away. And I just have 2x. Okay, so 2x is equal to negative 3. Now you should know what to do in this case. Okay, so whenever you have a number is equal to a coefficient and a variable like that, you're always going to divide. Oh, sorry, that's negative 2x. So I'm always going to divide by the number that's in front of that variable. Okay, so negative 2 divided by negative 2 means that I just have x on the right. Over here, a negative divided by negative is a positive. And if you use your calculator, you know that 3 divided by 2 is 1.5. But if you wanted to leave it as a fraction, oops, I'm at 3 over 2, then that's fine as well. But your answer is 3 over 2 or 1.5, and it should be positive because a negative divided by a negative is a positive. All right, and that's number 3. Okay, moving on to problem 4. Again, I see some distributive over here on the left, and then I also see some combined like terms on the right, but we'll get to that in a minute because I'm going to have to do that on the left too. So let's start with that distributive. I'll leave my 5x and my minus 1 the same, but now I have negative 3 times x, which means minus 3x. And then I have negative 3 times negative 2. So notice how I'm taking the sign of whatever's in front of that number. Okay, so negative 3 times negative 2 is positive 6. And that is equal to, let's just leave this as it is for right now. So 3x plus 5 minus x. All right, so that was our distributive property. Now let's go ahead and do our zero pairs / combined like terms. So on the left, I see a 5x and a minus 3x. So that's going to combine to just 2x. Then I see a negative 1 and a positive 6. So altogether, that's going to equal positive 5. All right, on the right, like I said before, I can combine that 3x and that minus x. All right, so 3x minus x just gives me 2x. And then I'll keep that plus 5. Now, right now, you should have a little red flag going up in your head because I have the exact same thing on both sides. If I have the exact same thing on both sides, then there is never a case where these two will not equal each other, right? No matter what I put for x, it has to be the same thing over here. So no matter what, this would be correct, which means my answer is infinite solutions. Okay, so once you get to that point, if you recognize that, you don't have to keep going. You can leave it as 2x plus 5 equals 2x plus 5, but this is your answer right here. Okay, if I wanted to continue this, I could. Okay, so I'll just continue it down here. I have 2x plus 5 equals 2x plus 5. I could take away 2 x's from both sides. Then I would have 5 equals 5. Now, is there ever a case where 5 does not equal 5? No, right? I could also take away 5 from both sides. Now I have nothing left on either side. Okay, so whenever you get to a case like this, it is always infinite solutions because it does not matter what I put in for x, it will always be true. All right, so really quickly, I've got about a minute left. I'm going to go over number 5 on here. Okay, so this one is saying Beyonce solved this equation and got the solution x equals 2. Jay-Z solved it and got a different answer. He got no solution. We are trying to figure out who is correct or if neither is correct. So there's a couple ways that we could do this. We could substitute 2 in for x over here. Remember how we were solving our equations before and checking our answers. Or we can just go ahead and solve it. So if I have negative 2x minus 2 is equal to negative 2 times 5 minus x. Okay, first step is distributive, so I'm going to leave everything the same on the left. Over here I have negative 2 times 5, which is negative 10. Then I have negative 2 times negative x, which will make this positive 2x. All right, now I've got x's on both sides. I don't like negative x's, so I'm going to add 2x to both sides. Now negative 2x plus 2x makes those cancel out. I still have negative 2 on the left, but now I have negative 10 plus 4x on the right. Going quick because I'm almost out of time. I'm going to add 10 to both sides so that I have 10 plus negative 2 is 8. Those go away, so I have 4x is equal to 8. Now you should all know if I divide both sides by 4, I get x is equal to 2, or 2 is equal to x, same thing. So we know that Beyonce was right.